There are thousands of car crashes every day. Every time a car crashes, the airbag detonates in order to protect the passenger. According, do you really know what happens inside this airbag? Chemistry is in every surface. There are several factors to consider in order for an airbag to be useful as a protective device. The bag must deploy and inflate within 40 milliseconds. The system must be able to detect the difference between a severe crash and a minor crash.
Here are the balanced chemical reactions that take place in the chemistry of a car airbag. The first equation is the one that is present at the start of the process, which starts with sodium azide, which is a crystalline solid at room temperature and it's an ionic compound. But since the sodium liberated is incredibly toxic, in the second reaction the sodium azide reacts with potassium oxide to transform into an alkaline silicate, a product which is no longer toxic. The alkaline silicate is an amorphous solid at room temperature and it's also an ionic compound. The ideal gas law is a state equation that summarizes the relationships that describe the response of an ideal gas to changes in pressure, volume, temperature, number of moles, and the constant R, which is a combination of Boyle, Avogadro's, and Charles' laws. The volume of the airbag that we will be analyzing is 70 liters at a temperature of 30 degrees. The calculations are the following. When you solve for quantity of moles, you get that you need 3.2 moles of nitrogen gas for the 70-liter airbag. Sodium azide, potassium nitrate, and silicon oxide are the initial reactants packed into the airbag module. 3.3 moles of sodium azide must be packed into the airbag module for the airbag to inflate. The decomposition of the sodium azide yields 3.3 moles of nitrogen gas. 2.7 grams of sodium are produced in the first reaction. 2 grams of potassium nitrate are needed to completely react with the sodium from the first reaction in the second reaction. The number of grams of KNO3 needed to completely react with sodium is 3.82.
The solid state has a definite volume and shape. As well, the molecules occupy a very rigid position. Also, solids have a high density. Solids can be divided into two categories, crystalline and amorphous. The crystalline solids have a strict and regular order, that is, their atoms, molecules, or ions occupy specific positions. A solid can be ionic, covalent, van der Waals, hydrogen bonds, or a combination of them. Amorphous solids are those that lack a regular three-dimensional distribution of atoms. These are generated when a solid is formed quickly. A clear example of this is a glass.
The entropy of a reaction determines if it is in order or disorder. The enthalpy of a reaction determines if it's exothermic or endothermic. Gibbs energy determines if it's spontaneous or non-spontaneous.
There is safety information that needs to be taken into account. Airbags contain sodium azide that produces nitrogen gas, which inflates the airbag. The reaction produces toxic chemicals. Sodium reacts explosively with water, and if sodium from a rupturing airbag gets into eyes, nose, or mouth of a passenger, the injuries could be dangerous. Potassium nitrate, which reacts with sodium to produce potassium oxide and sodium oxide, could also be dangerous. In case of contact with one of these substances, remove stained clothes. In case of inhalation, go to the hospital immediately. And in case of eye contact, wash eyes with cold water.
Compounds do not conduct electricity in the solid state.
Automobile airbags use a chemical compound that is so toxic that even small amounts can kill. Low enthalpy use a lower impact in the environment compared to high enthalpy.
The correct disposal when an airbag inflates in an accident is to return it to the company. Bring this type of waste to specialized centers so that they give you the appropriate treatment to avoid contamination as little as possible. These airbags could save your life. The main reason is because of the great speed that is executed. The speed is so fast that just when the person collides, the airbag is inflated. That is why it is highly useful to know what properties interact in these reactions, because with reactions like this, more lives can be saved in other situations. As a conclusion, I can say that stoichiometry is very important to the proper function of airbags. Without the careful calculations and measurements, airbags, a life-saving device, will be life-threatening.
Before this project, I thought that it was more like a mechanical process what happened inside an airbag. But I actually realized that it's more a chemical process than a mechanical process.
Also, we realized that even though it's an airbag that is supposed to save people, it does have like different things that may be dangerous for you, like all the compounds and the anything that are used inside it. So you should be dangerous also when it's deployed to be careful that nothing touched you, and if it did, like go to the hospital immediately. Thank you.